Okay, so now we will get into the nuts and bolts of what Python is and the different things that you can do with Python, and also the development environment. There are many choices that are available in how we can use Python, and the most popular one called Jupyter Notebook. And Jupyter stands for Julia, Python, and R. Basically, it was created for working with these three languages, Jupyter, Python, and R. But in the process that, it became really, really popular that, in fact, there are more languages that are being supported using Jupyter Notebook. And many of the work that happens in the data science machine learning world, you will see this Jupyter Notebook, which is very, very convenient to use and in an interactive way, and it helps you to learn much faster and work much easier. So that's the objective for this next session. So far, we've been doing a lot of theoretical discussions to set the stage, to set the context on why we are doing what we are doing. But now in this session, we will have time to do some demos and also get your hands dirty on doing on your own, and will require some Python installation. I'll provide some instructions on how to do that, and then we'll go from there. So background on Python, it's a very general purpose, object oriented. I think we should note that point that it can do any object oriented programming like any other languages such as C++ or a Java that can do. And it is a dynamic programming language. So I'll come to that in a bit about what dynamic programming means. But the key thing is that it is a language and environment primarily used for data science and graphics analysis. It is open source. It comes with a very rich ecosystem, lots and lots of libraries. And as I mentioned earlier, Python is very easy to learn, but it's very hard to master, because if you really want to be a master in this space, it requires lots and lots of effort from your side to be able to almost practice daily basis to understand all these language packages that are available. And there are many. And one beautiful thing in Python is that if you get stuck with some problem, the guarantee is that there is already someone already worked on it, and there is a package that is available. I'll show you some of the examples on how compact the number of lines of code that you would write with Python versus something else. But overall, that it doesn't take many lines of code that you would require if you do it in Java or a C or a C++ for that matter to achieve the same thing. And if you want to know more about Python, it has its own website called python.org, where it talks about its origin and the packages that are available. You can take a look at it. So why Python? So we keep saying Python and Python. Why it is very popular? It's very comprehensive. Anything can be developed in Python. As I mentioned earlier, you could write a web applications. You could write a API microservices. You can write database connectors. You can write machine learning applications. So anything that goes in software world pretty much can be done today with Python. It has the state-of-the-art graphics capabilities. That's one of the beautiful advantages that Python has than any other language. Of course, R has similar capabilities, but if you want to generate a complex graph that represents like multi-dimensional data, it's very hard to do that in other languages compared to Python. And it is designed for interactive analysis. Like basically, you send a command to the Python engine, then it processes it and sends back the results. So it's an interactive interaction that you have with the Python environments. And more importantly, like we discussed, it's open source. And if you go after some commercial packages, it costs thousands and thousands of dollars. and many companies, many industries are preferring today Python. If you go to LinkedIn jobs or Indeed or Glassdoor or any of the job vacancies today are for Python in the tech world. That all the cloud providers, cloud vendors support Python, and all these experiments are done in Python. That's why it's very popular. And from a capability standpoint, it supports variety of formats, comma separated values, Excel, database, all the things that we talked about. And it is extensible, thousands and thousands of libraries available. The list of libraries and the details that you can find in the pypy.org, pypi.org, that's where you would see all the libraries that are available. And there are commands that are available that you would use within Python to install them directly. You don't need to go to the website where you can use certain commands that you would do that within Python environment, that it automatically goes to this pypi website and then pulls that modules and libraries for you. And there are IDEs. IDEs stand for Integrated Development Environment, something called Spider, PyCharm, and Microsoft has a Visual Studio Code. And those are very much compatible, extensible for Python usage and easy to program. And it can run on any platform for that matter. It could be Mac machine if you have Mac, if you have Windows, if you have Linux. It works on all these machines, all these operating systems without any issues. So there is a guidelines that is published. It's called PEP, Python Enhancement Program, where it provides guidelines in terms of style, the recommendations, and it has multiple levels of guidelines. So if you go and say import this in Python, you get certain things like what you see on the screen called Zen of Python. It gives you the guidelines like beautiful is better than ugly. The one that I really like is the last one, in the face of ambiguity, refuse the temptation to guess. So those are some guidelines that are available online. You could find that in the python.org. If you want to know the meaning of each one of this, you can go to this website called inventwithpython.com, where there is a beautiful blog. It talks about how these things make Python even better, which I think not easily available in any other languages. So let's look at the history. It is created in 1991 by a gentleman called Guido von Rossum. It is designed as an alternative to scripting languages like Perl. As we discussed earlier, it's fully object-oriented programming. It competes with all the other compiled languages like C or C++ or Java. It's a dynamically typed language. It's called duck typing. There is a saying that if it walks like a duck, quacks like a duck, it must be pretty much a duck. So it's not very strict when it comes to this type management, how Python does versus other languages. For example, if it looks like an integer, if it behaves like an integer, it appears like an integer, then it must be an integer. So that's the ideology or analogy behind that. The example is that you don't necessarily need to specify when you are declaring a variable in Python and say that it is an integer. Let's say you declare a variable called x and say that it's an integer. In any other languages like C, C++, and Java, you would have to do that. You should have to do that. But in the case of Python, you just say x equal to 10. And if you assign the value of 10 to x, Python engine understands that what you're trying to do is creating a variable to hold an integer variable. So it creates the slot in the memory for storing 10, and it refers that with the identifier called x in this case, which holds the type of integer. And if you change x equal to something else, like for example a text, it automatically refers to a string type. So that's what we say that it's a dynamically typed language, and it's a JIT compilers. It's a just-in-time compiler, so the code compiles and runs in real time. What it means is that you type a code and you submit the code for the execution. You don't really need to make it as a machine readable code like you would do in other languages that we talked about. So it makes it an interpreter, not a compiler. And we also call REPL shell. The Python shell is a REPL shell. It's a read, evaluate, print loop shell. What it means is, again, that you submit the instruction and it reads it and evaluates it and prints the output, and that's what is being repeated in the shell. So it's called REPL shell.